This is a robotic arm. It may not look like much, but 1 year ago during a lab experiment, a friend who's controlling the arm got a bit too excited and moved it a little bit too much. I happened to be standing nearby, and bam. The bruise on my elbow didn't bother me much. It was not obvious or fatal despite lasting a few days. And this got me thinking, if incidents like this happen in a larger scale, not like your favorite sushi making robot in the fancy restaurant, think factory production, assembly lines. Now that kind of impact could prove lethal. According to the Journal of Occupational Hazard, impacts like these account for 44% of robot accidents, caused by either poor workplace design and human error. Now this makes sense because industrial robotic arms are rigid, solid and heavy, and due to this, they carry a lot of force and along with it, the momentum within an impact. This is where my project comes in. It explores the potential to have soft robots carry out the same tasks as their harder, rigid counterparts do. Now, soft robots, they are made of flexible material. They have been used for things like search and rescue, helping rehabilitation, all the way to ocean exploration. My project in this case utilizes air pressure to move the soft robot. Think of a balloon. You make it larger by blowing air in, and its shape changes. You then do the same by letting air out. Replace the balloon with the silicone rubber and you have one of the modules for my soft robot. After the simulation and design process, I ended up with 3 models. One for rotation, bending, and extension. After I had finished doing the manufacturing, I assembled these modules and began my testing. The results I obtained, well, they were somewhere within my expectations, I think. I first tested the rotation module, hoping that it will move like in the simulation footage. But alas, the uneven expansion caused by uneven wall thickness, plus the fact that one of the air chambers has a leak, the rotation module did not even move in the end. I consider this testing unsuccessful. The bending module thankfully showed more promising results. It managed to achieve a bending motion when expanding, however, this bending became obstructed by its own design. So instead of bending normally as it should, the module will now bend outwards when it reaches a certain limit. I had the most fun testing an extension module. Besides working exactly just as simulated, it managed to do what it was designed and expand to twice its length, which in case you didn't know, it was really awesome. So I consider this a great success. If we put all of these 3 parts together, we will get a complete soft robotic arm, which looks like this in the video. And we reached the end of the video, so I'd like to thank you all for watching until this point. Seriously, this project was quite a challenge and a very interesting experience for me. I'd like to also thank my supervisor, Mr. Kubun Hao, the lab technicians, Mr. Pania and Mr. Kilao, and the friends that helped and gave me advice along the way. Thank you all for making this project possible.